Last chapter we looked at the physical files on disk. But you in the database don't think in terms of raw files day to day. You think in terms of tablespaces. This chapter is the logical layer that sits on top of those files, and it comes up constantly in interviews in two forms. Explain the logical to physical hierarchy, and name the standard tablespaces every database has. Both are very answerable once you see the structure. So let's build the hierarchy from the top down, connect it to the physical files, and then tour the tablespaces you'll find in every single Oracle database. Oracle separates logical storage, how you in the database think about space, from physical storage, which is the files from Chapter 7. The logical hierarchy has 4 levels, and being able to explain them from largest to smallest is a classic question. At the top is the tablespace, a logical container that groups related data. Inside it, each object, a table, or an index is stored as a segment. Each segment is made of one or more extents, which are contiguous chunks of space allocated together. And each extent is made of data blocks, the smallest unit Oracle actually reads and writes. So the chain is, a tablespace contains segments. Segments are built from extents, and extents are built from blocks. Practice saying that top to bottom, tablespace, segment, extent, block. Now the most important connection in the whole chapter, the bridge between logical and physical. A tablespace is made up of one or more data files. The tablespace is the logical container. The data files are the physical storage underneath it. And you grow a tablespace in one of 2 ways. You add more data files to it, or you let its existing data files grow. Here's the sentence to memorize, because interviewers ask this almost word for word. A tablespace is logical, a data file is physical, and a tablespace is built from one or more data files. That one line ties Chapter 7 and Chapter 8 together and answers a very common question cleanly. Logical container on top, physical files underneath. Say it like that and move on. Every database is created with a predictable set of tablespaces, and you should know what each is for. System holds the core data dictionary, Oracle's own metadata, and it must always be online. SYSAUX is the auxiliary companion to System. It holds supporting components like the performance repository, so they don't clutter System. Undo stores undo data, the before images, and it's important enough to get its own chapter, which is next. TEMP is the temporary tablespace used for sorts and other work that spills out of PGA memory. Remember that from Chapter 3. And there's usually a default tablespace like users for ordinary application data. Now the golden rule, and interviewers listen for it. Application objects go in user tablespaces, never in system. Putting app data in system is a rookie mistake. Let's dwell on that rule for a second because it matters. Application objects belong in their own user tablespaces, users or dedicated ones you create for a specific app. What you never do is drop application tables into system. Why does it matter so much? Because system holds the data dictionary, the database's own critical metadata. If application data fills system up, or corruption creeps in, you're now risking the entire database, not just one app. Keeping app data separate isn't fussiness. It protects the dictionary, and it gives you the freedom to back up, relocate, or take an application's data offline independently without touching the core of the database. So, dedicated tablespaces for apps, system reserved for Oracle. That separation is a hallmark of a well-run database. 2 modern defaults worth knowing. First, modern tablespaces are locally managed, which means Oracle tracks free and used space with a bitmap stored inside the tablespace itself, rather than in the data dictionary. It's faster and avoids contention, and since it's the default, you rarely have to think about it, but you should be able to say the term. Second, autoextend. A setting that lets a data file grow automatically when it fills up. Autoextend prevents a ton of tablespace full emergencies, which is great, but here's the important caveat. And it's a nice thing to volunteer in an interview. Always pair autoextend with a sensible maximum size. Otherwise, a runaway process, a bad query, a bulk load gone wrong, can quietly grow a file until it fills the entire disk and takes everything down with it. Here are the common tasks you should be able to describe, because they prove you've actually managed storage. You create a tablespace with create tablespace EAC, naming its data file and size, and notice I turned on autoextend with a max size right there in the command. You enlarge a tablespace one of two ways: resize an existing data file with alti-data-gaze data file resize, or add a new data file with alti-tablespace add data file. And for maintenance, you can take a tablespace offline, or set it read-only to protect data that never changes, like a completed fiscal year. Being able to list this menu, create, resize, add a data file, offline, read-only, is exactly the kind of practical fluency that separates someone who's read the docs from someone who's lived in the database. Let's inspect it live, because monitoring space is a genuinely daily DBA duty. 3 key views. DBA tablespaces lists the tablespaces themselves with their status and contents. You can see system and users are permanent, temp is temporary. DBA data files shows the physical data files behind those tablespaces and their sizes. And DBA free space, this is the one you'll run most, tells you how much room is left, which I've summed per tablespace here. A big part of the job is watching that free space and acting before a tablespace fills. So these 3 views together let you answer the questions that matter every single day. What tablespaces exist, what files back them, and how much room is left. We formally covered the DBA views in Chapter 17. Let's lock it in. The logical hierarchy runs tablespace, segment, extent, block, largest to smallest. A tablespace is logical, a data file is physical, and a tablespace is built from one or more data files. The standard tablespaces every database has are system, SYSAUX, undo, temp, and users, and you should know what each is for. Modern defaults are locally managed tablespaces and autoextend, and you always pair autoextend with a max size. And the golden rule: application objects go in user tablespaces, never in system. One of those standard tablespaces, undo, is important enough to get its own chapter, because undo is one of the most misunderstood and most asked topics in the whole interview. That's Chapter 9, and it's a high-value one.